My dear students, as we finish with the rest of the year in this new form of learning, I'm going to try very hard to make this easy for you. I'll explain the few last topics we need to cover, hopefully in a way that will help you understand. Before the break, we were working on sound, and now we only need to discuss some facts about the speed of sound, such as what factors have an impact on it. As you remember, sound waves move longitudinally. It means that the vibration of the particles is parallel to the motion of the wave. So basically, sound in air, which is the one that we are the most familiar with, has the air molecules vibrating back and forth, creating areas of larger concentration and lower concentration. These different concentration of molecules are what create the compression and the refraction areas. The speed of sound, or how fast sound travels, is determined by two factors. One factor is the type of medium on which it travels, and also the temperature. For instance, sound will move at different speeds if it's traveling through a solid, a liquid, or a gas. Where do you think sound will travel the fastest? In a solid, liquid, or a gas? If you guess that sound will travel faster in a solid, you are correct. The molecules on a solid are already closer to start with, so when they vibrate, they will very easily be crashing into one another, making all the molecules surrounding them also vibrate. As I mentioned earlier, temperature also has an effect on how fast sound travels. Sounds move faster at higher temperatures, so as you move from the desert, which is very hot, towards the North Pole, which is very cold, the speed of sound will be smaller. The average speed of sound in air at 0 degrees is 331 meters per second. If you move higher above 0 degrees Celsius, the speed increases by 0.6 meters. If you go below 0 degrees Celsius, the speed will decrease by 0.6 meters per second. Obviously, in the physics field, we need to have an equation in order to predict the speed of sound in different scenarios. So we have come up with an equation. In this equation, determine the speed of sound, we will use the already known speed of sound in air at 0 degrees, and then we are going to factor the temperature and 0.6 meters per second for every degree Celsius. In order for you to be able to do some problems on your own, I will demonstrate by doing an example. On this example, the question is, if a 512 Hz tuning fork produces a wave at 32 degrees Celsius, what will be its wavelength? So what we need to do is write down the data, or what we already know, and then find what formula we will need to use and apply it. You are now ready to work on the worksheet and do the problems on your own. Good luck. Let me know if you have any questions.